Hello and welcome. It's week 9 science, so we're having a look at the science around energy management. So this is how energy is actually managed within our body. Yesterday we briefly touched on the idea of the healthy weight index, and this is an incredibly central aspect of the subliminal messaging, is that we're setting up a framework which the body can refer to. So this is a set of referral statistics or referral ideal states which the body can refer to and say, well, what can we do to adapt ourselves to actually fit into that idea or that concept, that design, that blueprint. The first aspect of that we need to cover is that one size does not fit all, and indeed what would be a natural fat disposition physiology in general be for one person is not going to be identical for the needs of the next person. The first aspect of that you might think about is, well, when you're young you have different kind of energy disposition. So for example, if you're a 6-year-old, then you would expect to actually have different energy management systems completely to if you were, say, my age. I'm 54, and at 54 you wouldn't expect to have the identical energy management systems in place or an ideal set of blueprint things in place as for my 6-year-old Joseph. Equally, there's big differences between the best sort of energy management relationships between a woman and a man, and we have to take into account this variation between the genders. There are statistical changes that go on with what would be considered to be a healthy weight as you age, but of course, given the immortality work that we are involved in ourselves and what's happening with science today, these old statistics that we've been working with are fast getting out of date. So how do we manage that actually within TRIM? Posted up on the website will be a reference document which actually shows exactly how all this is put together, what the numbers are for the different ages and so on. Obviously TRIM is directed at people who are over 18 years of age, and it's also directed at women who are not pregnant. If you are pregnant or if you're below 18 and you're dealing with excessive weight, well then we certainly can still work with you within the TRIM process, but TRIM itself is not directed at people in that situation. So check out the technical details. If you've got that kind of mind, you can actually have a look at where you fit into these things, and indeed one of the most amusing or interesting aspects would be considering whether you are somebody who should be in the athletic domain or whether you should be somebody within the regular domain. Athletes have a completely different type of energy management system going on with them. You picture somebody, for example, cross-country skiing or some type of activity like that, or running a marathon. The energy management requirements of a person undergoing that type of physical activity are completely different to somebody like me whose idea of exercise is getting out of bed and walking off to the bathroom. So I'm treating this a bit lightly, but you understand there's a huge difference between a person with a normal type of energy consumption profile and somebody who is an athlete. However, within TRIM we have your body actually determine where it fits within that, and then it sets up that blueprint which is then referred to for all of these physiological processes. Okay, so we talked about fat and sugar. Let's have a look at the sugars to begin with. Where is sugar used within your body? Sugar is the primary component of all metabolic activity. It's also used to make all kinds of cellular components. So the cellular components you may not have thought about, for example, things like DNA. DNA is effectively a sugar. It's a sugar with a few other things involved with it, but the backbone of it, if you like, is made up of sugars. Many of the structures within the cell actually are composed of sugars as well. And of course, sugars will combine up with proteins or fats indeed to make more complex molecules, and without the sugars being available, then these molecules can't be created. So same sort of story emerges for fats. Fats are incredibly important for cellular structure. For example, the cell wall, and indeed all of the membranes of the cell, of which there are a great variety, are all made from fat. So the cell wall itself is almost pure fat. very clever fat at that in the way that it actually manages the operation, and particularly the trick of being able to bring water-based or water-soluble molecules across it. The chemistry in that is quite remarkable, but nonetheless the cell wall itself is made from fat. Same story we talked about with the sugar. In the case of fat, the fats will combine with proteins to make special molecules to do all kinds of things within the body, and without that fat component, then we couldn't operate in any sort of imaginable way that we have within our bodies. Some places that you mightn't imagine that there's very much fat at all would be amongst all of the nervous tissue. So the outer layer of the nerves is called the myelin, and myelin is a fat. It's a fatty product. It's quite complex how it's actually put together, but nonetheless it is a fatty tissue. And I'm not going to go into the particular science that's involved in the transferal from a fat, or the change from a fat to a sugar. It's a very detailed and complex subject, which I'm more than happy to talk to you about individually or through the Facebook group, or indeed if there's sufficient request, I'll put together a resource where you can go and find the physiological information on that subject. It's enough for us to be aware that the sugars and the fats are in continuous communication and transference from one to another, and between all the different types of fat, all the different types of sugar as well. Okay, so I hope you found that useful and interesting. I look forward to your comments in the Facebook group, and enjoy the trim journey. So thanks for watching.